This is the first update for Gallian abstract algebra. It's all of section 0. I attempted all 65 problems, of which 37 were proofs. And so my total count for this book so far is attempted 37 proofs out of the 65 problems. There are a total of 1,688 problems in the book, and 34 sections and no appendices. Unlike other books, I'm not going to keep track of every single problem. Actually, I think for as long as possible, I will be attempting every single problem anyways. Yeah, I think so. All right, so then I wanted to mention that I do have access to the solutions manual. Paid $55 for this book, almost like 50 cents a page. It was a little expensive, but I needed it. Now, of course, given that I think I found a typo when I was checking section 0, I think I'll be very careful with the answers. Yeah, so this is actually by the author, and it has explained answers to all the problems, all the odd number problems, most of them. There's a few odd number problems that are not answered. I think I caught one that didn't have an answer. So there you have it. This book is actually, I think, hard to find, but for me, it was well worth the $55. Now, onto the book. I've been wanting to do this book for a while. I actually had a moment of happiness in my commute the other day. I was reading in the book and I was like, oh, finally, a thing. Finally, I am at the gates of this book. This update may be a little longer because it'll have its own anecdote. Years ago, before I started this channel, so now 5 years ago, my other earlier edition of this book, I started reading in section 0, and I was like, I have no idea what he's talking about. And that's what made me go and learn number theory. And I was going to only learn number theory and then come back to Gallian. But then I learned number theory and I wanted to understand analysis better. So I went into analysis. And then I realized that I also needed some linear algebra. So basically, every single thing that I've done in this channel up to this point has led me to this book and this point. Yes, you will see other videos where I show a gazillion abstract algebra books that I now have, way too many for what I need, but it's still, for me, all about Gallian. So I'm not going to make a separate video for this book because this book is going to get extensive coverage by the fact that I'm going to cover the whole book. So let this first video in the series suffice for that video. So it's a groups first, rings second book. It does not have modules, but it's really extensive in the coverage. I really like that it is completely self-sufficient. That is, and of course, I'm going to try to go slower in case you want to stop and read the table of contents. This book is available in PDF on the web. It's got zillions of uses and printings and whatnot. So you can easily download from the web a PDF to read what I'm showing you now. That's why I'm not really stopping that slowly. I notice that I say a lot of ahs when I talk. I'm going to try to not do that, but I think I'm just engineered that way. So yeah, the preliminaries are some basic set theory, some basic number theory, and of course he uses, I keep doing it's going to be very hard for me not to do that. I'm just going to be myself. See, I did it again. So he uses a lot of check digits to explain some number theory, and I found the material really fun. A little bit of logic gates, some complex numbers, mathematical induction, then equivalence relations, functions, function composition. Yeah, that's it. So that's really what he considers like what you need to know to get started with abstract algebra the Gallian way. And there are 65 problems. I attempted it all. There are some computer exercises. I will not be attempting them. There are true and false exercises off of his website. I will be attempting those and we'll be showing them here. But it so happens that the first batch is for section 0 and section 1, so that will go in the next update. Okay, so that was a very long introduction because of the way I'm saving myself from making another video on Gallian. So the reading, this was perfect for me because this is very little reading, tons of problems. And that is something that I really like to do. I love doing problems, even when I get them wrong. So yeah, I did some reading, solved for myself, as always, the examples. And then when I started on the problems, I tried to do some things even in the book by myself before looking at the answer, and I got 2 wrong. So I was like, yeah, I see my problem. I got that problem right, got these right, but incredibly enough, I messed up 2 of the mods. That's silly. I should have not missed any of them. This proof I had seen before, so it was easy for me to do. Whenever, of course, I feel comfortable about a proof, I put the little bars, and when I leave it empty, I'm not comfortable about it. And so I've reviewed 11, and you'll see it in the back. I just couldn't get 14. It's a shame that I didn't have an answer for it. I tried pretty hard. Yeah, this one, I didn't go through all of the equivalence classes, but it's correct. This one I got right. This one I was close. This is Euler's, the infinity of primes proof that you see in every number theory book, but I tried to do it from memory and I got close. Euclid's proof. Yeah, that's who it is. Yeah, these were easy problems. I think this is straightforward. This one, I just went and looked for a prime gap. That's really the answer. You can find 200 integers that are composites, but very nice trick in the answer, 200 factorial plus 2. Well played. I did not think of that. Yeah, this one was a really nice problem. I could figure out that it was 47. I started from the 70s all the way down the gap. And then I followed the book, and I think I did it correctly. I believe it doesn't have an answer in the book, but I'm pretty sure I got it right. 33, no. I basically restated the theorems without really doing what needed to be done, and I have reviewed it since. I think I got the Fibonacci one. I tried it. I'm not sure. This was easy. Just multiply them out, and you'll see that with induction, the induction hypothesis, you say it's true, and everything else is divisible by 9. So at first I thought that I had this wrong, and I was going to review it, but when I started reviewing it from the answers, I realized that actually I did get it right. I just answered it very briefly, and that's okay. 43 I've reviewed. 43, the answer has the typo in the answers book. I'm pretty sure it does. I got this wrong. Oh well. Got that check digit wrong. These I got right. All these calculations for check digits, I messed that one up. And then the long proof, I rewrote whatever was in the book. And then just to fill in, I just like to have the whole proof. I got this wrong. At first, I erased it. I thought, there's something fishy here. But I did not think of it this way, so I should have thought of it that way. Yeah, 61, I think I got right. Actually, I was doubting myself, but yeah, I did get it right. And 63, I got right, both of them. And then I reviewed 11, 33, and 43. I just went through what the answer in the book had, and sure enough, yeah, there's a mistake in the book, in the answers book. Because it's really 2 times A9 to A1 plus A0. And the calculations work out only when you assume that, which is correct. So the answers book has a typo. That's section 0 of Gallian.